Hello everybody, this is Rob Swatsky from the York campus of Hack, and welcome back to my Biology 121 Anatomy and Physiology 1 course. This is podcast 2.4a, Properties of Water. Out of all the many compounds found in living things, water is by far the most common and most important. Life simply cannot exist without water. Why is this compound so essential for life? Let's examine the properties of water that make life possible. The first property of water is that it's a powerful and flexible solvent. A solvent is a chemical substance that is able to dissolve another substance, called a solute. When a solute is dissolved and evenly distributed in a solvent, a solution is formed. A common water-based or aqueous solution produced by the body is sweat, which consists of water, the solvent, and its dissolved salts, the solutes. As a solvent, water provides an excellent environment for the body's metabolic reactions. Because water is a polar molecule held together by polar covalent bonds, it has both positively and negatively charged areas. The hydrogen end carries a partial positive charge, and the oxygen end a partial negative charge. This makes water especially capable of dissolving chemical substances that carry a charge, such as ions, or other polar molecules. Like dissolves like. Hydrophilic solutes, such as salt and sugar, can easily dissolve in water because they carry a charge or contain polar covalent bonds. These solutes are described as being water-soluble. The term hydrophilic means water-loving, which describes the chemical attraction these solutes have with water. For example, when crystals of the ionic compound sodium chloride are placed into water, the positively charged hydrogen ends of the water molecules are attracted to the negatively charged chlorine ions, and the negatively charged oxygen ends of the water molecules are attracted to the positively charged sodium ions. As the water molecules dissolve sodium chloride, they surround the sodium and chlorine ions and keep them separate from each other. This process is called dissociation. By hydrating the sodium and chloride ions, they are less likely to collide and reform their ionic bonds back into sodium chloride. But water does have limitations regarding what it can and cannot dissolve. Hydrophobic molecules cannot dissolve in water because they contain mostly nonpolar covalent bonds and are uncharged. These molecules are described as being insoluble in water. The term hydrophobic means water-fearing, which describes their lack of attraction to water. Examples of hydrophobic molecules include lipids, such as fats and oils. A second property of water is that it provides an excellent environment for the body's metabolic reactions. Water can play the part of either a reactant or product depending upon the reaction. In hydrolysis reactions, water is a reactant that helps break down larger nutrient molecules into smaller building blocks in the various decomposition reactions of digestion. In dehydration synthesis reactions, two smaller molecules are covalently bonded together to form a larger molecule. For every bond formed, a water molecule is generated as one of the products. One way to help you remember this reaction is through the word dehydration, which we commonly use to mean a loss of water. An example of a dehydration synthesis reaction is when amino acids are bonded together to form larger proteins during protein synthesis. A third property of water is its high heat capacity, which means water can absorb and release a large quantity of heat without drastically changing its own temperature. Water is able to do this because of the many hydrogen bonds holding water molecules together. When water absorbs heat, some of the water's hydrogen bonds are broken. This reduces the amount of heat energy available to speed up the movement of water molecules, which would increase water's temperature as a result. Because a large percentage of the body's mass consists of water, the body is better adapted to maintain its temperature homeostasis with the changing temperature of the surrounding environment. Water also has a high heat of vaporization, which means that it takes a large amount of heat to vaporize water from a liquid into a gas. This also plays an important role in body temperature homeostasis. When water evaporates from the skin surface during perspiration, it removes a lot of heat, which has a cooling effect on the body. A fourth property of water is its role as a lubricant, acting as the main ingredient in the body's various secretions. For example, water comprises the mucus secreted throughout the digestive tract, which helps food smoothly slide along from organ to organ. It is the main component of the serous fluids that help lubricate the body cavities, allowing organs to slide against each other with a minimum of friction. Water also makes up the synovial fluid secreted by the joint cavities, helping the bones and connective tissues move past each other. Thanks for watching, and please feel free to contact me by email at rjswatzk@hack.edu if you have any questions or comments about the course.